Hello guys, today the topic of discussion is pulse modulation. What is pulse modulation? Pulse modulation is a type of modulation in which the signal is transmitted in the form of pulses. It can be used to transmit analog information. In pulse modulation, continuous signals are sampled at regular intervals. Pulse modulation can be classified into two major categories. First one is analog and second one is digital. Analog In analog pulse modulation, sample amplitude is infinitely variable. In digital pulse modulation, it indicates sample amplitude at the nearest predetermined level. Now the pulse modulation. Before we proceed to pulse modulation, let me know types of modulation are there are two types of modulation. First one is continuous wave modulation, which is further classified into two categories: amplitude modulation and angle modulation. And angle modulation is further classified into two categories: frequency modulation and phase modulation, which we have covered in class. So today we are going to proceed with pulse modulation, which is classified into two categories: analog modulation and digital modulation. Analog modulation is further classified into three categories: pulse amplitude modulation, pulse width modulation, pulse position modulation. Now we come to digital modulation. Digital modulation is classified into pulse code modulation, which is further classified into delta modulation. Now we come to pulse modulation of part analog modulation, and the first one pulse amplitude modulation. It is the simplest form of pulse modulation. In this type of modulation, each sample is made proportional to the amplitude of the signal at the instant of sampling. The pulse amplitude signal follows the amplitude of the original signal as the signal traces out the path of whole wave. Here a signal which is sampled at Nyquist rate can be reconstructed by passing it through an efficient low-pass filter with exact cutoff frequency. It is very easy to generate and demodulate pulse amplitude modulation. This technique transmits the data by encoding the amplitude of a series of signal pulses. So here we can see our input message signal is a sinusoidal message signal, and the sampling signal is used in which produces the output pulse amplitude signal, in which we can see the pulse amplitude modulation. The amplitude of a pulses are same as it is of the message signal, only we have taken at the particular intervals of time. Now we come to the advantages of pulse amplitude modulation: easy construction of transmitter and receiver circuits. Both modulation and demodulation are simple. Now we come to disadvantages of pulse amplitude modulation. It is more noisy. It requires large bandwidth for transmission. Here the amplitude is varying, therefore the power required will be more. Now the applications of pulse amplitude modulation. Many microcontrollers use this technique in order to generate control signals, mainly used in Ethernet communication. It acts as an electronic driver for LED circuits. It is used in photobiology. Now we come to the pulse amplitude in pulse modulation, in which angle modulation, and second part pulse width modulation. Pulse width modulation is also known as a pulse duration modulation. Here the name suggests that width of the pulses is varied in proportional to the amplitude of a signal. Since the width is changing, the power loss can be reduced when compared to the pulse amplitude signal. So here we can see that our input message signal is a sinusoidal message signal and pulse width modulation. As the amplitude is increasing, the pulse width is increasing, and as the amplitude is decreasing, the pulse width is thinner and getting thinner. And so if again our amplitude is increasing, then pulse width is again increasing. So it is clear from the figure that amplitude of signal is constant. Amplitude limiters are used for this. Since clipping of amplitude at desired level take place, this modulation produces less noise. Now we come to the advantages of pulse width modulation. It has an efficiency of about 90%. It has low power consumption. It has high power handling capacity, and it is less noise interference. Disadvantage of pulse width modulation. Voltage spikes can be seen. The circuit is more complex. Switching losses will be more due to high pulse width modulation frequency. The system is expensive as it uses semiconductor devices. Applications of pulse width modulation. It is used to control brightness in a smart lighting system. It is used in encoding purposes in the telecommunication system. It is used in audio and video amplifiers. Helps to prevent overheating in LEDs while maintaining its brightness. Now we come to pulse position modulation. In this type of modulation, both the amplitude and width of pulse are kept constant. We vary the position of each pulse with reference to a particular pulse. Here a single pulse is transmitted with the required number of phase shifts. So we can say that pulse position modulation is an analog modulation scheme where the amplitude and width of the pulse are kept constant, while the position of pulse with respect to the position of a reference pulse is varied according to the instantaneous value of message signal. Pulse position modulation can be obtained from pulse width modulation. This is done by getting rid of leading edge and bodies of pulse width modulation pulses. The main advantage of pulse position modulation is that it requires constant transmitter power output, while the major disadvantage is that it depends upon the transmitter-receiver synchronization. Now the advantages of the pulse position modulation. Among all three types, it has the most power efficient as it has constant amplitude, noise interference is less, requires less power when compared to pulse amplitude modulation, requires less power when disadvantage of pulse position modulation. It requires less power when compared to pulse amplitude modulation. The system is highly complex. The system requires more bandwidth. Now we come to the applications of pulse position modulation. It is used in the air traffic control system and telecommunication systems. Remote controlled cars, planes, trains use pulse code modulations. It is used to compress data and hence it is used for storage. Thank you guys.